Hey guys, what's up? This is YouTube channel Proton Classes, and this video is Solid State Part 4. First here we are going to study closed pack structures. In closed pack structures there are types. First is one dimension, second is two dimension, and then third one is three dimensions, which exists in nature. One dimension, two dimension doesn't exist in nature. Now in one dimension, spheres are arranged in a row and touching each other, means in only a single axis, whether it be x-axis, y-axis or z-axis. Here the spheres are arranged along a line. Now, the important thing to learn is coordination number. Coordination number. Now, what is a coordination number? Coordination number, the number of nearest neighbors of particle. The number of nearest neighbors of particles. For example, take an sphere X. This sphere has how many nearest neighbors? This 1 and 2. Therefore, coordination number is 2. In one dimension, coordination number is 2. And what is this coordination number? Coordination number means number of spheres, number of nearest spheres to a particular sphere. This is a particular sphere. How many nearest spheres are there? There is 1 and 2. Therefore, the coordination number is 2. Now, two dimensions. In two dimensions, spheres are along x-axis also, x-axis and y-axis both, along both axes, x-axis and y-axis. Now there are two common ways in which horizontal rows can be arranged. The first row can be arranged like one dimensional. These are spheres, third sphere and fourth sphere. Now the spheres are how spheres are arranged. There are two ways. First way is just one above the another. It's this shape. This is what we get. This is called square close packing, and this is triple A type arrangement. Why triple type arrangement? Because this is first layer, second layer, third layer, all are identical to first layer. Therefore, when it is called A, therefore then it is also called to be A, then A. Therefore, this is triple A type arrangement. The spheres of two rows are aligned horizontally as well as vertically. They are aligned horizontally and therefore they are aligned vertically also. Now, why it is called square close packing? This is called square close packing because first find the coordination number in square close packing. The coordination number is 4 because let's take a particular sphere X. How many spheres are its nearest neighbors? This 1, 2, 3 and 4. Therefore, 4 spheres are nearest neighbors. Therefore, 4 is the coordination number. 4 is the coordination number. And this packing is called square close packing. Because how we get square close packing? Just join the nearest spheres. Just join the centers of nearest sphere. This one and this one. Just join the centers. This, and what we get is a square. That's why it is called square close packing. Now, second type of packing is hexagonal close packing. How can we get hexagonal close packing? Just it's very simple. This is one dimensional, and when we arrange in y-axis also, then we get two dimensional. But how we get hexagonal close packing? By arranging the next spheres in the dip of, this is dip or called depressions, this is dip or called depression, dip or depression. When we arrange the spheres along the dip or depression, then we get hexagonal close packing. Now this the type of arrangement is AB type. Why? Because this is row A and this is row B. These A and B rows are not identical, they are different. Therefore, this is called AB type. When both rows are same, then it is called AB type. But in this type, the first row and second row both are differently aligned. Therefore, it is called AB type. There is less free space. There is less free space. Why there is less free space? Because there is more gap, more empty space in square close packing, but in hexagonal close packing there is less gap or less empty space. Therefore, its efficiency is also high. In hexagonal close packing, efficiency is also high. Now, coming to coordination number. What is the coordination number for hexagonal close packing? Now, this let us take a particular sphere X. How many spheres are its nearest neighbor? 1, 2, 3, 4, 5, and 6. There are 6 nearest neighbors, nearest spheres. Therefore, the coordination number of hexagonal close packing is 6. Now, why did it call hexagonal close packing? Because when we join the centers of spheres of its nearest neighbors, when join centers of spheres of nearest neighbor, what we got is hexagonal. Therefore, it is called hexagonal close packing. Now, there are some voids, empty spaces. These are called voids or empty spaces. These. But there are two different types of voids. How? Two different types of voids like this. Voids are generally in triangular shape, but two different types of triangle. Here the apex is upwards. Here the second one apex is downwards. Here apex is upward. The significance of these type of voids we will discuss it later. Now, three-dimensional close packing. Three-dimensional close packing. Three-dimensional close packing from two-dimensional square close packing. The first layer is square close packed. Square close pack. What are square pack? Let's revise. These are square close packs when arranged just one above the another, not in the dip. Remember, not in the dip. When we arrange the spheres, the B layer along the dip, then we got the hexagonal close packing. The second layer is placed over the first layer, such as spheres of upper layer are exactly above those of the first layer. This is first layer, this is second layer, just above the first layer. This is a triple A type pattern. Now, how we get the three-dimensional structure? Like this. Three-dimensional structure is when we arrange these spheres, and above these spheres, just above these spheres, we align two spheres. Then we will get this type of three-dimensional shape when uh, one just one above the another. The base layer is a square close pack layer. This is a triple A type pattern because this is also a this is also all layers are just similar to one another. The lattice thus arranged is a simple cubic lattice. This is called simple cubic lattice, which we got from square close packed structures. When we got from what we got from square close packed layers is a three-dimensional simple cubic lattice, and its unit cell is called primitive cubic unit cell. Just remember it, its lattice is called primitive cubic unit cell. Now, three-dimensional close packing from two-dimensional hexagonal close packing. This we will do in next video. Thanks for watching.